So this video is for those of you who want to understand everything on functions. But we are going to start with an introduction to functions, which is relations and functions. Okay? So this video is going to cover almost everything that we need to know under functions. So let's begin. So what is relation? So basically when we're talking about relation, one thing should come in your mind is that a relation is just basically a set of relationship between two sets of numbers. So if you have got two sets of numbers, now how do they relate to each other? That is relation. Okay? Now, what is a function? So basically a function is a special type of relation. So there is a relationship between a relation and function. We said that relation is just basically the relation is a set of relationship between two sets of numbers. So sometimes we can say that relation is expressed using order pairs, but a function is a special type of relation. A special type is of relation, so it's more like a function is inside relation. Okay, we can have a pair or a set of pairs, and then that set of pairs, it can either be a function or not a function, but it's relation. Okay, but a function, it is inside the relation. Okay, for example, let me give an example. If I give you, let's say we have a, b, c, d. Okay, let's have this. Then we also have another one here to be equal to w, x, y, z. So this, we are going to have a relation here, but we need to understand, is this relation a function? Okay, so this is x and this is y. Now whenever we are talking about relation, you discover that you are going to have the x values and the y values. So the x values is what we call the domain, then the y values is what we call the range. Now one thing I want you guys to understand is that as we are going to proceed with this topic, functions, we're going to reach at a point where we're going to be talking about the domain and range. So these things are coming from here. Domain is basically the x values, range is basically the y values. Okay, for example, if you have been given, in this case they ask you to say list the domain. So the domain here is a, b, c, d. What of range? Range is w, x, y, and z. Okay, so let's now map this. Let's say that a goes to y, b goes to x, then c goes to x as well. So b goes to x, then c goes to x as well, then d goes to w, like that. So this is a relation, but is it a function? So for you to know that this is a function, there is one thing that we need to know. Okay, so for you to know that this is a function we say that is a set of, it's a special type of relation where each input has exactly one output. So each input, each input here should have what? An output. So this is an input. This is what we call the input, the x values. This is the output. So for you to know that this is a function, for each input, okay, we are supposed to have only one output, exactly one output. So for example, if I check here, okay, I have a has got only one output, which is y. B has got one output, which is x. C has got one output, which is x as well. D has got one output, which is y. Then we can conclude that this is a function. So this is a function. have concluded that this is a function because for each input has got only one output. Let me give you an example. Let's take, for instance, we have got y is equal to 2x squared plus 2. So if I have got two values of x, those two values of x, I'm supposed to get one value of y. That's what we mean. So you can have two values of x giving you one value of y. That is okay. So for example, here we have got x, we have got b and c. So b and c is a domain. So you can have multiple x values going to one value of y, but not one value of x going to two values of y. No, then that is not a function. Take note there. So this is a function because each input has got the exact one output. That's a function. Okay, let's have another example. So let's say we have the same things: a, b, c, d. So we have w, x, y, and z. Let's see. So I say that this is a domain, so this is x and that is y. At the same time, you can say x is input, like I said, then y is output. Okay, so now if I do this, a goes to z, okay, then let b go to x, but again I want b to go to y. Okay, then let c go to w, then d let it go to x. So this is a relation, quite okay, but is this a function? I told you to say the value of x, okay, the x value can only give me one value of y. But if I check b here, b is giving me x and also it goes to y. So it's not possible. I cannot have one value of x giving me two values of y. Therefore, this is not a function. So this is not a function because one value of x maps into two values of y. So this is not a function. So I can give an example. The best example I can give you is x. You can think x as maybe a marriage. Let's say there is a wife and a husband. You know that a husband can have, it's possible in other culture, it's possible that a husband can have more than one wife. Okay, so for example, we are saying that two values, so this we can say this is a husband and this is a wife. Why am I saying this? Okay, I think I've interchanged them. So the husband has to be y because that is one. So this is the husband, I'm going to explain, and this is the wife. The x is the wife. So I can have two wives get married to one husband. That is okay. Two ladies get married to one man. It's fine. Three ladies get married to one man. That is okay. But it is not possible for two husbands to get married to one wife. It's not possible. Okay, so that's the relationship which I want you guys to understand. So the x values is basically a wife, the y values is a husband. So a husband can have multiple wives. So the x values, they can come even the three of them, they can map into one y. For example, if I have x, y, z, then here I have a, b, c. So I can have, it's possible I can have that. Okay, that is a function because this is x, this is y. So one x value is giving me three values Okay, actually that is not possible because one x is giving me three values of y, which is not possible. But the opposite, so this is not a function. The opposite should be true. If I put it like this, okay, we say 2x variables goes to just, or 3x variables goes to one guy. Okay, that is okay. But again, we'll talk more about this. So let me give you another example. So the one I've given you here, I've not concluded that it's a function. I'll just give you an example. So let's have another example. So let's say we have, I'm going to use the same thing. I'm going to use A, B, C, D. So here I have X, W, X, Y, Z. So I have this. So this is X and this is Y. X is domain, Y is range. So let X, okay, let X goes to, this one goes there. Let B go to X, like that. Then C will not go to anything. Then let's do that. Okay, so let me get rid of Z. I just put Y, like that. So are we going to conclude that this is a function? Okay, so this is not a function. Okay, so now one thing I want you to understand is that for every input must have an output, but for every output should not have an input. It's okay. So for every input, if I have got any value should at least map to Y. So here I've remained with this. This C has not mapped to anything. So then this is not a function. But if C was in Y, then we can say that is a function. Okay? I hope you are getting the logic there. I want you to understand. Okay? So for example, if I give you this, let's say A, B, C, then here I have W, X, Y, Z. You can have a value of X. What I mean here is this. So this goes there, this goes there, then this goes there. So for at least for every input has got an output. So we don't care whether the output has got an input. We do not care about that. Okay, so this is a function. Okay, but again, apart from us knowing this, we need also to know the types of function. There's what we call one-to-one function. So if I have got A, B, C, D, W, X, Y, Z, so then I can say that this, if this one goes here, this one goes there, this one goes here, this one goes there. So this is what we call one-to-one function. Why are we calling it one-to-one function? Because for every value of X is mapped into only one value of Y. Therefore this is one-to-one function. Okay, but now how do you prove that something is or a function is one-to-one function? Okay, so there is a formula which we use. There are two formulas which I'm going to show you. There is what we call f of A should be equal to f of B. Why are we saying this? Because for every value of X should only map to one value of Y. So other books will say x1 should be equal to x2, like that. For example, let's say you want to prove, okay, you want to prove that you want to prove that the square root, let's say maybe you want to prove that the square root of maybe the function is like this. So you want to prove that this is 1 to 1. Is it 1 to 1 or not? So for you to know that this is 1 to 1, you know that for a function to be 1 to 1, so you say for a function to be considered as 1 to 1, f of a should be equal to f of b. So then we can say that the square root of a, where there is x, just replace a, should be equal to the square root of b. So we are trying to make a as a subject of formula. So I'm going to square both sides. Okay? Because I'm trying to make x as a subject of formula. So then square root and square root will cancel, a will be equal to b. So then if a is equal to b, then this is 1 to 1 function. So this is how you can prove actually. You can also prove using a graph. This function goes like that. So if this function goes like that, it only touches one point at x. That's why it is 1 to 1 function. Okay? So let's say we have another example. How can we show that it is 1 to 1? So let's say you have maybe f of x being equal to 5 divided by 3 minus 2x. So for you to prove that a function is 1 to 1, f of b should be equal to f of a, or f of a should be equal to f of b. So where there is a, so I'll say 5 divided by 3 minus 2a should be equal to 5 divided by 3 minus 2b. Then we can now, I want to make a as a subject of formula. If I cross multiply, I'll have 5, 3 minus 2b, okay, should be equal to 5, 3 minus 2a. So now I can cancel 5. I have 5 both sides. So then I have 3, 2b should be equal to 3 minus 2a. Shift 2a to the other side, and then it's going to be here. Then shift 3 to go to the other side, and then negative 2b to the other side is going to be like that. So this will give me 0. 2a is equal to 2b. So 2 and 2 can cancel. Therefore, a is equal to b. So now a is equal to b. That is, we say that if a is equal to b, then that is a 1 to 1 function. So therefore, this is 1 to 1 function. Okay? So this is what we are supposed to know under 1 to 1 function. But now let's also talk about it. There is also what we call one to many, or main to 1. Let me just start with main to 1. Let's say we have x, y, z, or what I can do is I'm going to use x1, x2, x3. And then here I have y1, y2, y3. This is what I'm going to use. So this is x and that's y. So if x goes to, if this one goes there, this one goes there, this one goes here. So this is a function because for every member of x has at least mapped into y. But we do not care about the values of y. Okay? Yeah, we do not care about the values of y. So now, what is happening here is, so two values of x have gone into one value of y. So many values of x have gone into just one value of y. So that's what we call main to 1 function. Okay? Then there's also what we call one to many. So if we say one to many is basically not a function, because one to many is like you have this. Okay, one to many is like we have this. So now what is happening is one value, okay, one value of x will go to many values. That's what it means. So this is this is one to many. So one value of x has gone to many values of y, but this is not a function because it's not possible. We cannot have a value of x going to two values of y. Not possible. So that's not a function. Okay. Then there's also what we call onto function. Onto function is a function where you have got maybe four values just mapping into one value of y. That is what we call onto function. So for example, let me give an example of, let's say we have f of x is equal to x squared. Now this is x squared. So if I plot this, I know that one-to-one function should only touch once. Okay, should only be one-sided. So x squared is basically like that. If I sketch it, so then it has got this side and that side. Then it's not one-to-one function. But how can I show that it's not one-to-one function? So you do the same. So here now I'm going to use this, but if you want you can use a and b. So where there is x, I'm going to put that, I square it, x2, I square it. So make x as a subject of formula, so I'll square root both sides. So if I square root this side here, I'll have plus or minus. So I'll have x1, x and the square root and the 2 will cancel out. I'll have plus or minus x2. So then meaning I have got now 2. x1 is equal to plus or minus x2. So I've got x is equal to positive x2 and x is equal to negative x2. So I can only conclude that it is one-to-one when I have got this positive positive. So therefore this is not one-to-one. So this is the basic idea behind the relations and function. Okay.